FreeU, Free Lunch in Diffusion UNet. In this paper, we uncover the untapped potential of Diffusion UNet, which serves as a free lunch that substantially improves the generation quality on the fly. We initially investigate the key contributions of the UNet architecture to the denoising process and identify that its main backbone primarily contributes to denoising, whereas its skip connections mainly introduce high-frequency features into the decoder module, causing the network to overlook the backbone semantics. Capitalizing on this discovery, we propose a simple yet effective method termed FreeU that enhances generation quality without additional training or fine-tuning. Our key insight is to strategically reweight the contributions sourced from the UNet skip connections and backbone feature maps to leverage the strengths of both components of the UNet architecture. Promising results on image and video generation tasks demonstrate that our FreeU can be readily integrated to existing diffusion models, for example, Stable Diffusion, DreamBooth, Model Scope, Re-render and Reversion, to improve the generation quality with only a few lines of code. All you need is to adjust two scaling factors during inference: project's website, project's website. The DreamLLM, Synergistic Multimodal Comprehension and Creation. This paper presents DreamLLM, a learning framework that first achieves versatile multimodal large language models, empowered with frequently overlooked synergy between multimodal comprehension and creation. DreamLLM operates on two fundamental principles. The first focuses on the generative modeling of both language and image posteriors by direct sampling in the raw multimodal space. This approach circumvents the limitations and information loss inherent to external feature extractors like CLIP, and a more thorough multimodal understanding is obtained. Second, DreamLLM fosters the generation of raw, interleaved documents modeling both text and image contents, along with unstructured layouts. This allows DreamLLM to learn all conditional, marginal, and joint multimodal distributions effectively. As a result, DreamLLM is the first MLLM capable of generating free-form interleaved content. Comprehensive experiments highlight DreamLLM's superior performance as a zero-shot multimodal generalist, reaping from the enhanced learning synergy. Cosmos 2.5, a multimodal literate model. We present Cosmos 2.5, a multimodal literate model for machine reading of text-intensive images. Pre-trained on large-scale text-intensive images, Cosmos 2.5 excels in two distinct yet cooperative transcription tasks. 1. Generating spatially aware text blocks, where each block of text is assigned its spatial coordinates within the image. And 2. Producing structured text output that captures styles and structures into the Markdown format. This unified multimodal literate capability is achieved through a shared transformer architecture, task-specific prompts, and flexible text representations. We evaluate Cosmos 2.5 on end-to-end document-level text recognition and image-to-markdown text generation. Furthermore, the model can be readily adapted for any text-intensive image understanding task, with different prompts through supervised fine-tuning, making it a general-purpose tool for real-world applications involving text-rich images. This work also paves the way for the future scaling of multimodal large language models. Chain of verification reduces hallucination in large language models. Generation of plausible yet incorrect factual information termed hallucination is an unsolved issue in large language models. We study the ability of language models to deliberate on the responses they give in order to correct their mistakes. We develop the chain of verification COVE method, whereby the model first drafts an initial response, then plans verification questions to fact-check its draft, answers those questions independently so the answers are not biased by other responses, and generates its final verified response. In experiments, we show COVE decreases hallucinations across a variety of tasks, from list-based questions from Wikidata closed book, multispan QA and long-form text generation. LMDX, language model-based document information, extraction and localization. Large language models, LLM, have revolutionized natural language processing, NLP, improving state-of-the-art on many existing tasks and exhibiting emergent capabilities. However, LLMs have not yet been successfully applied on semi-structured document information extraction, which is at the core of many document processing workflows and consists of extracting key entities from a visually rich document, VRD, given a predefined target schema. The main obstacles to LLM adoption in that task have been the absence of layout encoding within LLMs, critical for a high-quality extraction, and the lack of a grounding mechanism ensuring the answer is not hallucinated. In this paper, we introduce language model-based document information extraction and localization, LMDX, a methodology to adapt arbitrary LLMs for document information extraction. LMDX can do extraction of singular, repeated, and hierarchical entities, both with and without training data, while providing grounding guarantees and localizing the entities within the document. In particular, we apply LMDX to the Palm-2S LLM and evaluate it on VRDU and Chord benchmarks, setting a new state-of-the-art and showing how LMDX enables the creation of high-quality, data-efficient parsers. A large-scale dataset for audio-language representation learning. The AI community has made significant strides in developing powerful foundation models, driven by large-scale multimodal datasets. However, in the audio representation learning community, the present audio-language datasets suffer from limitations such as insufficient volume, simplistic content, and arduous collection procedures. To tackle these challenges, we present an innovative and automatic audio caption generation pipeline based on a series of public tools or APIs and construct a large-scale, high-quality audio-language dataset named as AutoACD, comprising over 1.9 million audio text pairs. To demonstrate the effectiveness of the proposed dataset, we train popular models on our dataset and show performance improvement on various downstream tasks, namely audio language retrieval, audio captioning, environment classification. In addition, we establish a novel test set and provide a benchmark for audio text tasks. The proposed dataset will be released at the project's website. End-to-end speech recognition contextualization with large language models. In recent years, large language models, LLMs, have garnered significant attention from the research community due to their exceptional performance and generalization capabilities. In this paper, we introduce a novel method for contextualizing speech recognition models incorporating LLMs. Our approach casts speech recognition as a mixed-modal language modeling task based on a pre-trained LLM. We provide audio features, along with optional text tokens for context, to train the system to complete transcriptions in a decoder-only fashion. As a result, the system is implicitly incentivized to learn how to leverage unstructured contextual information during training. Our empirical results demonstrate a significant improvement in performance, with a 6% WAR reduction when additional textual context is provided. Moreover, we find that our method performs competitively and improves by 7.5% UR overall, and 17% WAR on rare words against a baseline contextualized RNT system that has been trained on more than 25 times larger speech dataset. Overall, we demonstrate that by only adding a handful number of trainable parameters via adapters, we can unlock contextualized speech recognition capability for the pre-trained LLM while keeping the same text-only input functionality. The Languini Kitchen, enabling language modeling research at different scales of compute. The Languini Kitchen serves as both a research collective and codebase designed to empower researchers with limited computational resources to contribute meaningfully to the field of language modeling. We introduce an experimental protocol that enables model comparisons based on equivalent compute, measured in accelerator hours. The number of tokens on which a model is trained is defined by the model's throughput and the chosen compute class. Notably, this approach avoids constraints on critical hyperparameters, which affect total parameters or floating point operations. For evaluation, we pre-process an existing large, diverse, and high-quality dataset of books that surpasses existing academic benchmarks in quality, diversity, and document length. On it, we compare methods based on their empirical scaling trends, which are estimated through experiments at various levels of compute. This work also provides two baseline models: a feed-forward model derived from the GPT-2 architecture and a recurrent model in the form of a novel LSTM with 10-fold throughput. While the GPT baseline achieves better perplexity throughout all our levels of compute, our LSTM baseline exhibits a predictable and more favorable scaling law. This is due to the improved throughput and the need for fewer training tokens to achieve the same decrease in test perplexity. Extrapolating the scaling laws, leads of both models, results in an intersection at roughly 50,000 accelerator hours. We hope this work can serve as the foundation for meaningful and reproducible language modeling research. Controllable dynamic appearance for neural 3D portraits. Recent advances in neural radiance fields, NEAFs, have made it possible to reconstruct and reanimate dynamic portrait scenes with control over head pose, facial expressions, and viewing direction. However, training such models assumes photometric consistency. Over the deformed region, for example, the face must be evenly lit as it deforms with changing head pose and facial expression. Such photometric consistency across frames of a video is hard to maintain, even in studio environments, thus making the created reanimatable neural portraits prone to artifacts during reanimation. In this work, we propose CodeNRF, a system that enables the creation of fully controllable 3D portraits in real-world capture conditions. CodeNRF learns to approximate illumination-dependent effects via a dynamic appearance model in the canonical space that is conditioned on predicted surface normals and the facial expressions and head pose deformations. The surface normals prediction is guided using 3 DMM normals that act as a coarse prior for the normals of the human head, where direct prediction of normals is hard due to rigid and non-rigid deformations induced by head pose and facial expression changes. Using only a smartphone-captured short video of a subject for training, we demonstrate the effectiveness of our method on FreeU synthesis of a portrait scene with explicit head pose and expression controls and realistic lighting effects. The project's website can be found here, project's website.